Welcome Year 10. This is lesson 3 in the Physics 1.3 Making Use of Energy booklet. It's a bone in a beaker. Now I know that your bone is not got lots of purple dots in it at the moment, but it will do in a second. More about that in a moment now. So what we've got is question 1. What is the volume of the water after the bone has been added? You should be able to see here that the volume is in between 800 and 1000, so it's 900 millilitres or centimetres cubed. So that's your answer to question 1. Question 2. Before the bone was added, the water volume was 720 millilitres. With workings, show the volume of the bone. Well, when it's been added, it's 900. If you take away the original volume, 720, what you come up with is the volume of the bone, which is 180. Don't forget units, millilitres or centimetres cubed. Now, why have I coloured in the bone with all those little dots? Well, question 3. Using the terms particles and density, explain why this bone has sunk in the water. Add particles to the bone and to the water to visually reinforce your answer. Well, if I add in the particles to the water, which I'm going to attempt to do now, the water particles are more spaced out. They are less dense than the bone. So of course, because the particles in the bone are closer together, it means that the bone is denser, which means it sinks to the bottom. So you can explain that definitely using these terms here, particles and density, and explain why the bone has sunk. Okay, so that's nice and easy to start off with. So let us move on. Why is density so important for electricity generation? Water is approximately 1,000 times denser than air. This means that when water moves through a turbine blade, there is more mass of material moving through, which means there's more kinetic energy. Moving water is a very efficient way of generating electricity. When you've got large amount of water moving at speed, like through a hydroelectric power station, it generates a huge amount of electricity. The generators at the foot of the Hoover Dam in Nevada, as shown here, provide more than enough energy for the city of Las Vegas with all its bright lights. Okay, we have seen that density has the units grams per centimetre cubed, but if the units were mass in kilograms and the volume in meters cubed, then the units for density would be slightly different. It would be kilograms per metre cubed. Now, to answer these questions, which you do in the lined paper here, you need to know the equation for density. Remember, you get that from the front of your booklet. Density equals mass divided by the volume. You should be able to complete these questions. So hires, definitely pause this now. Foundations, stay with me. So here we go. I'm going to have a go at the first question for you foundations. It's asking for the density, so you write that equation down. Then we include the workings, the mass in grams. 101.05 divided by the volume, which is in centimeters cubed, 100, and that gives us a value of 1.0105. Don't forget your units. You need to know the units for density is grams per centimetre cubed. You can have a go at question 2 on your own. That's just asking what the density of air is. That's nice and simple. For foundations, in this last question is asking for the volume. So you've got to rearrange the equation. So I will do that for you. It will be done in the exam. Volume equals the mass divided by the density. Put your workings in, get an answer, and don't forget the units here for volume will be in meters cubed. Okay, so here are some extra questions. All hires do this, absolutely. And to be honest, the foundations give it a go as well. Okay, give it a go. Remember that density equals mass divided by volume, or volume equals mass divided by density, or if you need to isolate mass, mass equals density times by the volume. Okay, so have a go at those. Moving on, pause the video if you need to, of course. Have a read through this and highlight what you feel is relevant. Have a read through this as well. Basically what it's saying is when you get to buy a house, make sure it's energy efficient. Otherwise you're just wasting energy. And if you're wasting energy, you are wasting money on your electricity and gas bills. That would be, in my own words, proper stupid. Let us move on. We have here an energy efficiency rating for a house. When you buy a house, new or old, you will get an energy efficiency rating. Okay, A being the best, G being not very good. Now, at the moment, it would appear that the current rating for this house is low, is 37. That's no good. With adding in all of these options, for example, double glazing, low energy lighting, I've done that, cavity wall insulation, you could increase the efficiency of your house up to 73, a C grade house, not quite A, but a C grade. Now, what are the total savings made by the homeowner per year? What you do, show your workings, you just add up those figures. Add up those figures. And then what would be your savings per month? Well, it's whatever value you got here in pounds and pence, and divide it by how many months in a year? There's 12, and you'll get your answer. Moving on. Have a read through this, highlighting what makes sense. Okay, insulation reduces the flow of heat energy from somewhere hot to somewhere cold by reducing the effect of the 3 ways that heat can be moved. Now, heat can move from hot to cold by number 1, conduction, number 2, convection, and number 3, radiation. Please write down these 3 sentences that describe those methods by which heat can move. You should be pausing the video now so that I'm writing this up. Then, final thing, Draft excluders work by reducing convection currents under a door or through gaps. They can save between 10 to 20% of a household's heating costs. So let's go through this now. No draft excluder. So inside, what you get is hot air rising and cool air dropping down. That is convection currents for you. But as this hot air rises, cold air from the outside can be drawn in. This cools the house down, which causes your bills to go up. Now, what you do is this. You can't stop hot air rising, and you can't stop cold air. Come on. Cold air dropping. You can't stop that. But if you put insulation or a draft excluder at the bottom of a door, it prevents the cold air getting in. That is stopped. Doesn't happen. Well worth putting draft excluders indoors. Anyway, that's the end of this lesson. Well done.